Back to another video, guys. This is all about revision for GCSE iGCSE program. I will consider 2D shapes. Here are gonna be circles, and we encounter with ratios in geometry. Ratios for example, for the radii of those circles and semicircles, or probably a ratio of the perimeters and areas. That's all about that. So make sure you remember the main formula related to the area, perimeter, how to find that, because it's very significant in this case. And here is the first question for the problem. Fix that, grab your notes, grab your pens, and this is the second part of that problem. So also fix that, try to do by your own, and then let's see my explanations. Alright, so here in the first part of the problem, we need to establish the right equation that connects radius of the large semicircle with the radius of the small one. Okay, so it's all about construction. So what I'm gonna do, I'm gonna mark the center of the small semicircle is gonna be here, and right above that's gonna be the center of the large semicircle. I'll put the center O in this case. Okay, why? Because due to the principle of symmetry, the small inscribed semicircle will share the common point, which is the center with their large semicircle. Alright, obviously it's pretty intuitively clear. And what I'm gonna do, I'm gonna put radius this way and this way, okay? That's gonna be the radius for the small semicircle. I put the small r. And also I'll change the color into yellow one, and also from the center to the point where you have the touching point of small semicircle and the large one, I put the big radius here. Okay, that's going to be the radius of large semicircle. And obviously those small radii are small will arrange 90 degrees angle, because this point is the peak or the maximum point of this small semicircle, and it's just right above O1. So obviously that's going to be that will arrange 90 degrees angle. They will be perpendicular to each other. So hence we've got a right angle triangle. Let's put a point A. So triangle AOO1 is the right angle, so it's right angled. Okay. So that means we can apply Pythagoras. I just transfer that here. And we apply Pythagoras. Due to Pythagoras theorem, we can arrange the equation that connects hypotenuse, in this case, with their two legs, which is going to be r squared and r squared. Is going to be 2r squared. But if you like, you can take the square root of both sides. Okay, and that means we will arrive to the equation that connects to radius, okay, of the small and large semicircle. That's going to be the first base equation that we're going to use in the following consideration. Alright, so what we need to do, we need to define the ratio of the areas. So let it be the small area to the big one, as we're required to do. So small semicircle area to the largest one. Okay, so as you remember, any area, for example, the small area is going to be pi r squared, while the big one is going to be pi big R squared. And in this case, if we just put this in this ratio, we'll get the ratio of the square of the radius. Okay, it's going to be r squared small to the r squared, which is big one. And hence we've got the ratio of the squares. So ratio of the squares can pick up from the previous equation from there, and that means we'll get 1/2. Okay, if we messed up and got 2, for example, just check for the right sense. So this is the smaller area, and area of the small semicircle obviously is smaller than the area of the big one. So if you got 2 for some reason, you just need to check yourself. Okay, so what about perimeters? Alright, so perimeters is basically the length of the boundary. So I'm going to use dashed lines. It's going to be here, and it's going to be around semicircle. So just put dashed line in this way. So this is the length of the boundary, okay? So you have basically two diameter, okay? That's going to be a diameter, and diameter AD, for example. So small perimeter is going to be 2r, which is diameter, and you need to add up the half of the circumference length. So circumference length is 2 pi r, so you have that, and that means you need to add pi r in this case. Okay, so that's going to be, you can factorize and you'll get 2 plus pi. That's going to be the perimeter for the small one. And in the same way, if you're concerned about the perimeter of the large semicircle, which is here, so you can just change the small radius into the big one, and that's how you can arrange perimeter for the large semicircle. All right, so what we're gonna do, we just need to take the ratio, and obviously 2 plus pi and 2 plus pi, that's gonna be the same coefficient. So the ratio for the perimeters, I just put it here, of the big one to the of the small one to the big one, is gonna be just the ratio for the radius, okay? And that means it's gonna be 1 square root of 2, okay? That's how we got the ratio that we are asked to do, okay? So we've got everything here. All right, small space, sorry for that. Okay, and we just go to the next part. So actually I need to return back for a while, because here, what do you see? We used the formula for the area of the whole circles. So that's why it's better to use coefficient 1/2, because we have a half, right? So we have a half of the whole circle area. That means we're gonna use the semicircle's area, which is a half of the full one. However, finally, if you have this 1/2 ratio, so we've got basically canceling those fractions, 1/2, 1/2, and eventually it won't have any influence on the final result. Just a little amendments here. Okay, so here in the part B, what we're gonna do, we need to find the area of the sector. So for this reason, what I'm gonna do, I'm going to shade this sector in this way, okay? That what we're gonna to determine the complete area, okay, of this sector, and that's why we need to remember the formula for the sector's area. Okay, so we have, if we mark the small radius as r, we're gonna use notation area of the sector as alpha is the angle 32. I just use first the general formula. So it's basically the fraction alpha in 360 of the whole circle area, which is pi r squared. Okay, basically you're taking the fraction of the whole circle's area. Just make sure you remember this. But in our case, we are given the big radius. Large circle has a radius of 2 centimeters. So that means we need to remember that we express r squared as 2r small r squared. So that means we can express it through the big radius as r squared over 2. In our case, r is 2 centimeters, which will deliver us the formula for 4/2, which is just 2 centimeters squared. So that's r squared, and we just plug values into the formula. So 32 into 360 and times 2 pi, which is going to be actually the area of the sector, which is shaded here. All right, so that's going to be a 2, and yeah, we have 2 completely. Okay, so 64 over 360 and times pi. Okay, so let's try to calculate that quick. So that's going to be 64 pi over 360, which will deliver us the answer for the final sector's area as 056 centimeters squared, correct to 2 decimal places. Alright, so that was basically nested semicircles and the ratio and geometry for 2D shapes. So make sure you got this topic. Also, try to watch all other videos dedicated to 2D shapes. Also scaling factor, it's all about that as well. And the whole playlist dedicated to circles and circle geometry. Hope you like that. Don't forget to subscribe if you're new here. Don't forget to check out my dance channel if you type on YouTube Daniel Dallas how to dance. So you'll meet my channel and see you next time.